random go with myself. And you can see we have 6 LMU for D2 signals, and here it's 90 degrees and 90 degrees, and 6 times 15 is indeed 90 degrees, so it does work pretty well with other non-robotic agents. So,
firstly, I will introduce the research background.
Resource-limited environments and dynamic environments.
Yeah.
Empirical evaluation with that.
Introduce the modular construction.
Thank you.
It's our construction technology that mainly includes 3 stages. The first is the off-site manufacturing.
Furthermore, the bridges
manufacture the construction module of the factory, and that's the
inverted and
transported to the on-site for assembly. And it has some key benefits, include the productivity improvement and on-site manpower reduction, better construction environment, and better quality control. And the MSA inspection is an essential process in construction to ensure building works can comply with the prescribed code, standards, and regulations. Here are some examples of some typical modular inspection tasks. And however, currently modular construction have many challenges. The first is about accuracy, because it's necessary to detect all different steps, to detect all different defects to avoid the costly rework. And the efficiency challenge means that the inspection must be timely to avoid delays in factory and the work on the assembly on site. And the last one is the security, because the inspection data and the process.
So next presentation we have is the activity monitoring of
temporary
and large-scale objects.
Enable the mutual trust between the stakeholders. And based on this topic, I made a little review on the MSA inspection, and I found the relevant research can be divided.
So is the presenter of this presentation here?
Some are related to the machine learning, and some are related to blockchain technology. And in a summary, the MSA inspection work based on machine learning and can provide high accuracy and high automation level. But this method lacks a lack of security. This means that the inspection data, include the input and output, are vulnerable to data tampering, and the inspection process has limited transparency and security. And for the blockchain-only solutions, this has the advantage to ensure the data integrity, the traceability, and the transparency. But this method lack of intelligence and cannot execute the inspection work automatically. And therefore, the research gap can be summarized that pure machine learning and blockchain work cannot meet the practical requirement of the MSA inspection. And then I will introduce a conceptual framework which has been introduced in previous study. Here is a scientific paradigm that can be considered the integration between the machine learning and blockchain. And the aim of this paradigm is to optimize the practical balance between the accuracy, efficiency, and security for various different engineering management tasks. And it has some core benefits because the machine learning can be used to provide the advanced intelligence and efficiency, and the blockchain part can provide the enhanced data integrity security. And when they combine together, they can ensure the accuracy, efficiency, and the security of the engineering management will be used faster and to implement the MLOB paradigm, it includes 4 steps. The first is machine learning acquisition, and the next is the conversion, and the next is the safe loading, and the last is the consensus computing. And in another word, to summarize, can be shown as this figure. We can see that all the data input, the machine learning computing process, and the result output can be protected in the secure, safe environment in blockchain. And I will use a case study for illustration. And this project is a student resident in Hong Kong, and it includes 2 towers. Each tower have 17 floors, and totally have about 1,000 modules. All these construction modulars are manufactured in a factory in mainland China and then transported to Hong Kong for assembly. And therefore, the whole process, management process, has 3 key challenges. The first is the cross-border logistics. And the second is the high quality control standards. And the last is the multi-stakeholder coordination.
For the next experiment,
and based on the implementation, we propose we design a workflow. The first worker can upload the corresponding inspection record according to the checklist. The record includes some certificate, the description, and the supporting materials such as image and the document. And then when all these materials are uploaded to the system, and the blockchain smart contract can be automatically invoked to execute the machine learning based inspection logic, and all the data input and critical result can be automated, recorded in the blockchain distributed ledger. And we can see that if occurs disagree with the automatic inspection result, we can appeal it to invoke the human inspector to get the final decision. And here is an evaluation. We select a pure machine learning solution as a baseline method to evaluate the accuracy and efficiency and security. And here is the evaluation result. We can see that we select different models for comparison, and the model net V3 can achieve the highest accuracy, and compare with the and in conclusion, the proposed when comparing with the baseline method, the proposed method can achieve the same accuracy performance with the traditional method. And
probably missed it, but was it? Would you say that it was economically viable to construct instead of demolishing the Champlain Bridge at the end?
And we can
or do you have any numbers of
computation time.
Yeah.
In here
it's only slightly longer. It's about 20 milliseconds.
So we might not get
and
other.
The next part is the discussion and future works. And the contribution of this research is to first propose MLOB
for economic reasons
to the MiC inspection task, and it can enhance the mutual trust and accuracy, efficiency for MiC inspection task. However, this research also have some limitations. And the first is the MLB application is only verified on a single case, and lack of generalized.
So for the conclusion, we have
successfully on other engineering management task objects or MSA projects. And secondly is the scalability, because this work is only test on the evaluation result comes from a single model, and even though we have many limitations, scalability for some large scale MSA management projects. And for the future works, the first we need to analyze to more MSA scenarios, and secondly to address the computational resource constraints. And the last, we need to collaborate with industry for adoption. Okay, here's the end of my presentation, and thank you for your attention.